let's look at task 1 for the normalisation procedure. So this is our problem, which as a class we've seen. So using the data provided, convert to UNF and then first normal form, second normal form, and third normal form. Let's ensure that each table name is in the field is connectedly and there's a primary key identified. So here's our attributes that we've took from the problem. There we go, patient number, etc. We've taken them out and presented them in a better way for doing UNF. So we've got our patient name. Now let's transfer the data over. So here we go. Transferred the data we have in the example over, and at this point we need to be thinking about our UNF. So our UNF, every row should contain every attribute. So every row, there are our attributes or columns. Every record should contain every attribute. So let's make sure our duplicate data is actually in place. There we go. And once we're there, we are at UNF. Everything's unrolled. Each column or attribute contains only one value, and every row contains every attribute. So let's remember our first UNF rules: atomicity and no repeating data. So let's look for the repeating data at this point. So we can see patient number repeats, patient name repeats, ward number repeats, and ward name. So let's highlight that. Pick a nice little colour, and once we've highlighted it, we can see that's the repeating information. There is no other repeating information in this table, but we can see that there's possible candidate keys. So we'll get patient number, ward number is a possible candidate key, and we can see that drug number is a possible candidate key because it could possibly be unique just from the data set we're seeing. But from here we've got a repeating data, but let's go back to the question, and we can see that in the question patient number is the primary key. It's already told us we have a primary key, so from there we can change this to our primary key for our repeating data set, or repeating data subset. So there we go, we have our primary key. We leave the other candidate key as it is, which would now become a secondary key, but we'll leave it as candidate key. And to make it UNF, we remove any duplicate data, and with the rest of the data that was left over that's non-repeating, we need to link it back in a separate entity. So we can put the primary key that we identified, transfer it over as a foreign key, and link it to the data that was left. Patient number and drug number and our possible key can be used together to identify the second entity, like each record in it. Sorry. So there we go, and that means those two together become a primary key foreign key, so that both attributes are the key. There we go. And from there we are now UNF. We have removed all the repeating data. Foreign keys can repeat because they're primary keys from another entity. Let's remember our 2NF. It's a 1F and there is no dependencies. It's a whole key. It's dependent on the whole key. So because our first entity has a simple key, a primary key, it means it is already dependent on the whole key because there is only one attribute as a key. But the second entity has two possible parts of the primary key. So two attributes make up the key. So at this point we need to check the other non-key attributes to see if it's dependent on the whole key or only the partial key. So drug name, we could possibly say that drug name is dependent on just the drug number and doesn't really rely on the whole key, the patient number. So let's highlight that. And because drug name and description are linked, because it's the description of the drug, it means that the description is also dependent on the drug number and not just the patient number, so these aren't dependent on the whole key. So we go ahead and we take that out. Drug number then becomes just a primary key, and it's new entity, which means that new entity is now 2NF. And we're left over with the primary key, foreign key, and the other entity, which means all the attributes are now dependent on the whole key because that new entity is just 2 keys. So we are now at 2NF. So let's jump ahead and remember the rules of 3NF, no transitive functional dependencies. So that means every attribute should be dependent on the key and just the key. If there's any link between two non-key attributes, it means we've got a dependency and we need to break it up. So with this entity, it already is just 2 keys. There is no possible dependency on a non-key attribute. In this one, there's 2 non-key attributes, but they are dependent on the key and nothing but the key. So that's already 3NF. In this one, you can see that, well, it's possible that ward name and ward number could be linked because, well, there's a few ways of thinking it. You could say it's 2 different data sets, the 2 different topics of data, patient, ward, but we'll look at the keys. So patient name is dependent on the patient number, because to get the name you would need the patient number. The ward number of where the patient is could possibly be dependent on the patient number because it's linked. You search for the patient and you find their ward. But ward name's more dependent on the ward number because that's the unique identifier for it, which means we have a dependency there. We don't really need the patient number to find out the ward name. So we have a dependency. So as soon as we've identified the dependency, we just go ahead and take it out. We still need to know that that patient was on that ward, but that's fine. Oh, I'm going to go ahead and move these over. Give myself some room. There we go. And at that point, we take ward number out. Ward number was a candidate key, so it's fine. We can make that the primary key, and we leave ward number there in the previous entity as a foreign key, so we can still link the patient to the table. And it means that all the non-key attributes are now dependent on the whole key, which is the patient number in the first entity and ward number in the second. And that means we are now 3NF. To make the ER diagrams a bit easier, at this point we go ahead and we can identify the keys and the links. So patient name to patient name, foreign key, we'll go ahead and identify it with a nice little colour. That means that this is the relationship there. Ward name to ward number with a primary key, foreign key, again a relationship. And drug number to drug number with a primary key, foreign key, and R1. And from there we can see that it could be a one-to-many relationship on enough of them all. So the one side goes on the primary key if it's a one-to-many, with the foreign key being the many side. And from there you're basically set up to create your ER diagram. I hope that explains the normalization process pretty quickly.